Hi everyone, this second video is going to review simplifying radicals and a few other things. So for simplifying radicals, we do need to do some work by hand. We can use Desmos to help us, but not quite like evaluate and solve. So we are remembering the rules for when we simplify radicals. We're going to break apart a number with a factor tree, write out all the variables, circle pairs or triples based on square root or cube root, singles stay in, and groups go out. So simplify the cube root of 54. So we're going to do our factor tree, and remember we're going to be dividing by prime numbers. So let's try 54 divided by 2. We got, so 54 divided by 2 is 27. We cannot divide 27 by 2. Whoops. 27 divided by 2, we get a decimal. So let's try 3. That's 9. So 27 divided by 3 is 9. 9 divided by 3 is 3. And 3 divided by 3 is 1. Okay, so that is 54 broken down. I'm going to put these numbers under the radical, the ones on the outside here. That's 2 times 3 times 3 times 3. And this is cube root, so we are circling triples. Here are 3 3s. Singles stay in, that's the 2, and groups go out, that's the 3. So we get 3 cube root of 2, and we're done. Okay, our next problem, write in simplest form. This time we have both a number and variables. We'll do the factor tree for 18. 18 divided by 2 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. Now we stop. Under the radical, we're going to expand. 2 times 3 times 3. Then we have 3 x's, 1, 2, 3, and 6 y's. 1, 2, 3, 4, 5, 6. We are doing square root, so we're circling groups of 2. There we go. All right, and whatever we circled, those groups are coming out, and then the singles are staying in. So that is one group of 3, one group of x's, and 1, 2, 3 groups of y, and then the 2 and the x stay in. And we're done. Okay, we have a cube root with a few more variables here. We still do the same process, the factor tree of 32. So let's see, 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. And 2 divided by 2 is 1. So we're going to stop. Under the radical, we have 1, 2, 3, 4, 5 2's. And we have 9 A's. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2 B's and 3 C's. 4 C's, sorry. And now we're doing groups of 3 again. So that's 3 2's. And then here we go. 3 groups of A. There's no triples for B, so we don't circle anything. And then 1 group of C. And again, whatever we circled comes out. So that is 1 group of 2, 3 groups of A's, no B's, and 1 group of C. What's left inside is 2 times 2, which is 4. And then 2 B's, so B squared, and a C. And there's my cube root. And it is simplified. All right, the next one we're going to be doing is evaluating. We did that in the last video, but this time we're going to show you how to do it using Desmos. So here we go. So I already went ahead and I typed in this part, f of x equals 4x plus 5. Now we're going to push this wrench button or gear button, push a graph, and there we go. We have a table of values. Okay, but we're looking for when x equals -3, and I don't see that here. So all I do is go down in a new box, type in -3, and it tells me right there, my answer is -7. Easy, easy. All right, let's try it for letter B. Okay, I went ahead, I already typed it in. F of x equals -x squared plus x plus 15. whoops, I have a comma there. We don't want that. Okay, push the gear symbol, add a table, and then I'm looking for -8. Type it in for x, and then when x is -8, y is -57. That's also when the input is -8, the output is -57. All right, we're going to continue using a table here. Let's see, did I maybe have forgotten to put that one in? I did. So let's go ahead and clear this out. So we're going to go ahead and again type in y equals parentheses x plus 1 squared minus 3. I'm going to enter a table, and then these are the values I'm looking for. So I'm just going to change them. So that's -5, -3, we already have 0, and 4, and then I simply fill in the table. So that's going to be 13, 1, -2, and 22. Okay, so once again, if you're given an equation, you can type it straight in Desmos, push that gear symbol, and add a table. All right, line of best fit is, we're still going to be using tables, but it is a little bit different. Okay, so before we start, I want to go over what things look like. If something is linear and we have a scatter plot, it will look more or less like a line. Maybe negative, maybe positive, but it will be in the shape of a line. Quadratic is the parabola, so that's our U shape, maybe facing up, maybe facing down. But if it looks like that, that's quadratic. Exponential we'll talk more about later. It's when it goes like this. It might go up very quickly, or it could also go down very quickly. Okay, so linear like a line, quadratic is a parabola, exponential is a big swoop up or a big swoop down. Okay, here we go. Line of best fit. So what we're going to do first is type in exactly what we see. We're going to click this plus sign. And when you click the plus sign, there's a place to add a table. So it's a little bit different than when you start with an equation. I typed in all of my values, but you'll notice I did not put in the dollar sign. No dollar signs, no commas. All right. After I do that, so again, you push the plus sign, add a table, and fill in the values. The next step is you're going to push the magnifying glass, maybe, and there you go, and you can see your scatter plot kind of show up there. Then you're going to push these dots up here, and bam, it gives you an equation right here, and this is in slope-intercept form. Y equals mx plus b. So we're looking for the most close data. So we can see right away this is an increasing line, so negatives are not going to be part of our answer. And we're going to look carefully, and the slope is 2.24. So this one has 2.2 and this one has 65. So this is definitely our answer. We have the slope and the y-intercept. Okay, our last one, I'm going to start the same way. You're going to push the plus sign. You're going to add a table and fill in all of the values really carefully. Then we're going to push the magnifying glass. And it didn't give me my line. Let's see. And then we're going to push the 3 dots, and there we go. There is our line. So this one is a little bit different. It's not asking for our equation. It says the table below shows the data collected on the number of hours a group of students, so here are the hours, studied for the test, and the score each student then earned on the test. Based on the line of best fit, that's what this is here, what is the closest score a student would obtain for studying 4 hours? So we know that hours is our X value, our input. So what we could do is come over here, and we're looking to find, kind of scrolling up the line. Oops, doesn't want to do it. You have to hold the button down. We're going to go all the way up until we get to 4, and we're going to see what the output is when it's about 4. and we can see it's 74.8. The closest one to 74.8 is 75, and that is our answer. And that's it for this video. I hope it helped.